Hi, welcome to my channel Chemistry Class. With this today's video, I'm going to discuss about how to perform a calculation based on volumes of gases from balanced chemical equations. There's a small request at the beginning. Please subscribe our channel to encourage us to do more and more of this type of videos. Right? We are moving on to one example to look into this type of questions. We move on to balanced chemical equation. Calcium carbonate solid on heating break into decompose into calcium oxide solid and the carbon dioxide gas. So it is the example number 1. This is asking how it is to calculate volume of carbon dioxide if it is provided just 10 grams of calcium carbonate. What is the volume of carbon dioxide produced? The usual method is to find the number of moles of calcium carbonate and see how many moles of carbon dioxide form. But it's very easy. Within very short time, the answer can be taken. If you can get this, as the mass is given, you can calculate molar mass of this, the calcium carbonate. And you know, 1 mole of any gas occupy 24 decimeter cube at RTP. So at RTP, the volume of the gas occupies 24 decimeter cube. Now we can get the relationship volume. So the 1 mole of carbon dioxide, 24 decimeter cube of carbon dioxide is produced if 100 grams of calcium carbonate is reacted. So 1 grams of calcium carbonate always produce what is written to your right side divide by left side. So this much of decimeter cube carbon dioxide, but now it is used 10 grams of calcium carbonate. So the answer become 24 divided by 100 multiplied by 10. It should be 2.4 decimeter cube of carbon dioxide. So this kind of questions, it's very easier to get the relationship between asking thing and the given thing only, and this answer automatically comes with the correct units, because units are also very important rather than into your magnitude of this the question based. This is our example number 2. Lead nitrate on heating, it decomposes to form the lead oxide, nitrogen dioxide and oxygen. The question based on what volume of this the nitrogen dioxide form, at the same time the volume of oxygen form. It gives you the mass is 3.31 grams of lead nitrate. So the relationship of lead nitrate with this NO2 first, as well as the oxygen should be taken secondly. To get the very first part here, this is the volume of nitrogen dioxide. If it is reacted 331 grams of lead nitrate, it produces, which is this one time, it produces twice of nitrogen dioxide, produce 2 times 24 decimeter cube of nitrogen dioxide. When it uses 1 gram of lead nitrate, obviously it reacts and produces 2 times 24 divided by 331 decimeter cube of nitrogen dioxide. Now it uses 3.31 gram. So the answer become 2 times 24 divided by 331 multiplied by 3.31 decimeter cube of nitrogen dioxide. We can simplify that. 331 into this 331, it should be the 0.48. The answer would be in decimeter cube of nitrogen dioxide. I didn't use a calculator because it is, I can take this is minus 2 here. This is 331 get cancelled with this one. 2 times 24 is 48 times minus 2 become 0.48 decimeter cube of nitrogen dioxide. So the answer comes as this would be 0.48 without using the calculator even. So it is much faster if you can simplify in this way. Next part is the volume of the oxygen. So it is very clear 331 grams of lead nitrate When it is completely reacted, it produces half mole of oxygen, which occupy 12 decimeter cube of oxygen, because 24 decimeter cube occupied by 1 mole. Now it is the half mole is produced, so it's 12 decimeter cube. 1 grams of lead nitrate would produce, which would be, the answer is 12 divided by 331 decimeter cube of oxygen, but it uses up now 3.31 grams of lead nitrate. So the product would be 12 divided by 331. I can write down 331 times 10 to the power minus 2 decimeter cube also. Then these two get cancelled. The answer become 0.12 decimeter cube of oxygen. So without using calculator, it can be obtained. The answer is 0.12 decimeter cube, which is the answer would be for amount of the oxygen produced. This is the example number 3. This gives you sodium hydrogen carbonate. 2 of that would give you 1 CO2. You're asking what volume of CO2 is formed when 8.4 grams of this sodium hydrogen carbonate is used up. So the mass is given here for reactant is 8.4, and the MR for this one is 84, and the other information is being given would be mass here and asking the volume of carbon dioxide. It is easier to write down onto our right side. It is producing 1 mole of carbon dioxide, which is 24 decimeter cube produced if 2 times 84 grams of sodium hydrogen carbonate is used up. So obviously 1 gram would produce 24 divided by 2 times 84. Answer comes in decimeter cube of carbon dioxide by 1 gram of sodium hydrogen carbonate. Question is asking with 8.4 grams of sodium hydrogen carbonate. So the final answer will be 24 divided by 2 times 84 multiplied by, I can write this 8.4 as 84 times minus 1. The answer comes in decimeter cube. These two get cancelled. So it should be 12 minus 1 become 1.2 decimeter cube of carbon dioxide. So quite often it is not necessary to use a calculator either, and it's very clear the answer comes with the units. It is much faster by this method. Example number 4 I have chosen here. Iron trioxide is allowed to react with carbon monoxide. It produces in this one 480 decimeter cube of carbon dioxide is produced. Your question is what mass? So you are supposed to find the mass of iron oxide used up. For that, if you are getting the molar mass, 159.8 is the molar mass of iron trioxide. You are asking now what mass of iron oxide is now used up. So if it is like this, the 3 times. So you are asking to keep your answer what is needed here. 159.8 grams of iron trioxide is needed to use 3 times 24 decimeter cube of carbon dioxide. Now my known value is the carbon dioxide, which I need the answer is the mass of iron trioxide. So 1 decimeter cube of carbon dioxide to be obtained, 159.8 divided by 3 times 24 grams of iron trioxide is needed. Now to obtain 480 decimeter cube, 480 decimeter cube of carbon dioxide, 159.8 divided by 3 multiplied by 24, that's again into 480. Answer comes the mass of iron trioxide. So it is much clearer now. It is to be simplified by using this calculation. It is 159.8 has to be multiplied by 480, which comes as 76,704. 76,704, which can be divided 76,704 divided by 72 would be 3 times 24 would be the answer. So this has to be divided by 72 is 1065.3. 1065.3 grams of iron 3 oxide is needed. So this would be the answer which we can calculate. So the final answer become it is this equals to 1065. So it's the answer for this would be 1065.3 grams is the answer. So you can simplify further up even. I use the calculator for this one because I wanted to get the answer in somewhat less time. I have chosen the example number 5. It is asking that octane burn in oxygen. It is for balancing. I can write 25 divided by 2 or 12.5 oxygen. What volume of oxygen? This is the question mark here. Use up a 1600. Volume produced here 1600 decimeter cube of carbon dioxide. So it is that relationship between these two. So it is that 1600. What are known thing here would be you're asking the oxygen 12.5 times 24 decimeter cube of oxygen is needed if it is 8 times 24 decimeter cube of carbon dioxide to be produced. When this first sentence, if written very correctly, final answer automatically comes in the correct way. So it is that 8 times 24 decimeter cube, 12.5 times 24 decimeter cube of oxygen. Therefore, 1 decimeter cube carbon dioxide to be produced, it needs 12.5 times 24 decimeter cube of oxygen. Therefore, it is this divided by 8 times 24 decimeter cube of oxygen. That is 1 decimeter cube. Question is asking for 1600 decimeter cube. So obviously the final answer 12.5 into 24 divide by 8 times 24 times 1600. You can see 24 get cancelled. So it should be this equals to 200 and this become 1. So the final answer is it is that equals to 12.5 times 200. 8 times 8 times 2. So it is the final answer will become it is that 12.5 multiplied by 1600. So it is 20,000. That has to be divided by 8 times 24. Or else it is 200 multiplied by 12.5 multiplied by 200 and divided by that by 1. So the answer is 2500 decimeter cube. This much of oxygen is needed because in order to produce air, it should be used much more higher value of the oxygen because it is 12.5 is needed to react with 8 of them. So it is the ratio become 2500 decimeter cube of oxygen is the final answer. With today's video, I was trying to give some correct way and the easy approaches for question based on volume and the mass from the balanced chemical equations. I hope you understood. So please remember to subscribe our channel to motivate us to do more and more of this type of videos. Hoping to meet up you soon with another video. Thank you so much for watching the video.